I have a confession to make. I used to be a hardcore gamer. Now this is 12 years ago, but before I got married. My wife and I decided it'd be better that I'm not a hardcore gamer after marriage. But nonetheless, before I just loved first-person shooters. You know what's funny is 12 years later, I mean, that's a long time, right? Like more than a decade. I still know a lot of people who play video games, and they still play the same games I used to play. And I mean, maybe they're like part three or whatever, but the same thing. They just look a little better. You run around, you pick up weapons on the ground because everybody knows rocket launchers are just sitting behind cars, right? And you pick them up and shoot each other, you feel better. It's a great day. So anyway, when you're playing these games, that's the thing. When you first get into them, you find these weapons on the ground. A lot of times you haven't even seen them before, and you pick them up. Now, let me ask you this: when you're playing this, you pick up this thing. It looks like a rocket launcher or something. Do you stop right then? You're like, oh, whoa, whoa, whoa! Pause the game. Go over to another computer and say, okay, I just picked up a device that looks like a rocket launcher in Counter-Strike. How do I use this device? Google. No, you don't. What do? You shoot the thing. You're like, whoa, check that out. It blows up a car or something like that. That was amazing. And you start learning how to use it. Oh man, I didn't know I could snipe with this thing. I could zoom in, and I mean, you just start playing around and using it, and before long, you're a master of rocket launchers, right? Well, same thing in the Cisco world. Can I tell you, some of the best learning experiences you will ever have is when you're thrown into the boiling pot of water, and you have to kind of figure out how to make things work. Here we are in Access List. I've kind of changed the way I've taught Access List over the years. Last nugget, we went through this. Access List, it's not just for access. Talked about some of the uses, why we have these access lists. So in this nugget, I'm going to be getting into standard access control list syntax. And the way I'm going to approach this is kind of like a Counter-Strike rocket launcher. We're going to just dive right in, right? I'm going to say, here's the scenarios, and we'll discover the syntax as we go. Continuing our online gaming theme, one of the most famous maps in Counter-Strike is Dust, or Dust 2, that you're looking at right here. And whenever you're doing a first-person shooter, it's essential that you know the map. You know where people are hiding or could be hiding so that you can get them before they get you. In the same way, we're going to do a lot of configuration on access lists. It's essential that we know the map or the network diagram because we'll be using it for both this and the extended access list configuration coming up. So, looking right here, we've got three routers, router 1, 2, and 3. First off, I'll just throw this out there. Router 3 is our iOS XR router, so we can get a little XR love as we go. And here we are in a service provider series talking about the 192.168. Whatever networks, but it's just a subnet, right? So over on the left, we've got the /24 subnet, 192.168.1 connected to router 1. Also notice I've labeled all of the interfaces. It's going to be essential when we start figuring out where to apply it. So we've got a WAN link coming across, bridging router 1 and router 2 with the /30 mask. So here's .5, here's .6 of the .4 subnet. Same thing here, 10.1.1.0/30, .1 and .2 happening right there. Now notice this. Threw a little funky subnet mask love at us. 192.168.2.0/25. If your subnetting's a little rusty, let's break that out in binary. /25 is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's our class C, right? .1, 0, 0, 0, 0, 0, 0, 0. Right? This is essentially a class C with one more beyond it. What does that mean? Well, if we reverse engineer this and say, okay, well, that as a decimal number is not 18, 128. That's going to be our increment. So we would start from 192.168.2.0.2.128.2.256, which we go, okay, well, we can't have 256. I'm just adding 128, right? Can't have that. So let's fill in the end ranges. 192.168.2.0 through 127, 192.168.2. 128 through 255, right? So this /25 mask has really just broken one class C subnet into two different subnets, not labeled 0, 1 and 2. You can see the .2.0, so this will go up through 127 being the broadcast. Up here starts 128 through 255 being the broadcast, so we've carved that up. Now, why did you do that, Jeremy? Well, because as we get into our access list, you'll find out that wildcard masks are how we identify them. And knowing, I mean, Cisco certification exams love funky wildcard masks. You don't use them that often in the real world. I'm not saying never, but you just don't. You usually use normal subnets, but nonetheless, anything's possible. I mean, we're talking service providers, right? Anything is possible. So it will behoove you to know a lot of these funky wildcard masks that they could throw at you. Okay, that's the lay of the land. Now let's look at scenario 1. Use a standard access control list to block 10.1.1.1, which is this guy, from reaching 10.1.1.6, which is this guy, and 192.168.1.0, which is all of these guys, right? Two different things. Now, first rule that you want to be aware of with a standard access list is that you always apply a standard access list as close to the destination as possible. Why is that? Well, because standard access control lists can only block based on source address information, right? Extended are the one that can do all of the source, destination, protocol, port number, time range, blah, 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 all the different things that you can block on. Well, standard only blocks on the source. So if I were to create a standard access list that did this, right, what's our goal? To block 10.1.1. The only thing that I can do is I can say deny 10.1.1.1. That's it. Now, I can't say denied from what, I can't say denied from where, I can't, et cetera, et cetera. So if I were to go and I would say, oh, okay, well, there's 10.1.1.1, I'm going to go ahead and apply it right there, maybe outbound right there, right? What would it impact? Everything. Would I accomplish the goal? Well, yeah, but it's using a rocket launcher. Everything is blown up because this guy can't access anything because I can't specify what he's denied from. So rather, I might apply it maybe inbound here. Ooh, but even then, that wouldn't be good because then he'd be denied from accessing this, which is more than what it's asking. It's saying deny him from accessing this and that whole subnet there. So what I might do is say, okay, well let's apply it outbound right here, or maybe even better per Cisco. How about inbound right there? Is it kind of a bummer? Is there a lot of processing that might have to happen? Yeah, well, yeah. I mean, if I were to have a packet, it would have to go la da 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 da. I'm going, bam, and hit the wall right there. It has to cross the whole network to find out that it's denied. But that's the drawback, I guess you could say, of standard access lists. And can I just mention right now, this is not the rule for extended access lists. Extended access lists are as close to the source as possible because you can specify exactly what they're denied from before they even leave the gate, right? Okay. So when you are thinking about access lists, it's always best to visualize them before you go further. Before you put first configuration command in, you got to know what router are you on, right? So you have to think, okay, if I have to deny this guy from reaching these guys, right? Where am I? Well, I'm probably all the way over here on router 1 because that's as close to the destination as possible. Okay. You know what I did? I got smart. And I busted out secure CRT. I don't know why. You ever done something the same way for so many years? You can't even think of doing it another way. I have in my CBT Nuggets recording career always gone into PuTTY or TerraTerm, and I just create a telnet session each thing and kind of drag them in and out of the window. Whoa, Windows 7, don't shake it. It makes things disappear. I just kind of drag them in and out, but it's such a pain because I always forget which window is what and all that. And then all of a sudden, it hit me today. It's like, what's that movie? Dumb and Dumber, right? Where he's like Samsonite. Oh, anyway, it hit me today. Then I'm like, why am I doing that? Why can't I just label them all pretty and put them in one secure CRT? Or if you don't have $99 to throw at secure CRT, PuTTY Connection Manager can do the same thing. Idiot! Why didn't I think of that? 10 years later. Anyway. Dumb and Dumber things are already coming to my mind, so I'll save you. So I'm sitting on router 1 right now. What do I do? Right? Well, two phases to configure an access list. First is to set up the access list itself. Then it's to apply it. You might remember from the previous nugget where I talked all about ACLs. I said they're not just for access. Could be used for NAT, could be used for quality of service, could be used for VPNs, could be used for blah, 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 blah. Down the list we go. So you can create them and they do nothing. They can just sit there until you actually apply them. Now, first thing to catch is type in configure T the right way. I'm going to use named access lists. See, the old school way of doing access lists is by using just the access list command and typing in a number. And based on the number you type in, it dictates what kind of access list it is, right? So I could say access list 50, and I would get my own little set of commands, permit, question mark. By the way, live and breathe the question mark with access lists. They will help you learn the syntax to where you can just do it off the top of your head, but that question mark is so handy. So I'm saying access list per 50, permit. Now this list of commands is because I said access list 50. It put me into this standard range. Check this out. If I were to back this out and say access list 150, first thing you see is, whoa, 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 look at this. We got a little bonus command. Instead of having deny, permit, and remark being the old option, now I have deny dynamic, because that's an extended access list feature, permit, and remark. And then when I hit, I'll say, well, let's permit, hit the question mark. Before we just got 3 commands right here with the standard. Now the Cisco router recognizes, oh, because you're typing in 150, you're doing an extended access list. Okay, here, let me give you all these commands. I don't use numbered access lists at all anymore. I would say, maybe if they're on an exam, it's about it, right? Now, I would say just about all Cisco with me uses named access lists. So instead of typing in access list and a number, even though that's still valid, type in access list. Oh, that's not it. IP access list and a name. No, well, okay, hang on. IP access list, what kind of access list is it? So I can say standard or extended. You can see these are just kind of maintenance commands. Standard or extended. We're going to do standard access list right now. Then you type in the name. Now you can use quote unquote named access lists with numbers, but again, nobody uses the numbers. Just type in a name. So the beauty of a name, you can just type in word, whatever you want, is that it's much easier to remember. So instead of access list 25, I can type in access list standard, let's just say block 10111. Right? Just a nice logical name that I can use. Now, I probably wouldn't use a name like that, but just for this example, why not? It is case sensitive, so I got to remember all capital. I hit enter. Now notice it takes me into this named access list configuration mode. Now I get to do my permit and deny commands. Now notice at the very top I've got this sequence number. This is pretty awesome. With Cisco access lists, it didn't used to be this way long ago. It's like basic programming. Yeah, if you remember BASIC, my first real computer was a Commodore Amiga, and you got this basic programming language. I would do line 10, echo, hello world. Then I would say line 20, go to 10. And what that would do is, run that program, and it would just create a loop where it does hello world, hello, just filling up the whole screen. And I'm like, I'm a programmer, genius. Well, same kind of thing with extended access lists or any access list is I can go in there, I can say, okay, sequence 10, deny this, sequence 20, permit this. Now, it processes them in order, but this also gives me the flexibility to squeeze lines in there. I can say, oh, I forgot to do something. Let me make it line number 5 or line number 6 and squeeze it in there. Or I could remove a line. I could say no 20 and yank that line out of the processing and put another line in its place. So it's very cool. They're just like little placeholders. Now, if you do nothing, if you just ignore that and type in permit and deny, by default, the router will sequence by 10. So the first command you type in gets the sequence number of 10. The next command you type in gets 20, and so on. Now you may have also noticed this command resequence. IP access list resequence. So here's the cool thing is, let's say this access list is old, years go by and you keep updating it and you squeeze stuff in 11, 12, 13, and you kind of max out, right? You're like, I've maxed my little gap out there. I got to like blow the whole thing away and recreate it, right? No, I can go and do resequence, which takes them and spreads them out with new numbers again. You can just say, you know what? I want to use a resequence increment of 10, and so what happens? 5 will become 10, 10 will become 20, 11 will become 30. It just renumbers it for you to give you those big gaps back. I'm ahead of myself, but I thought it was pretty cool. So what am I going to do? I'm going to create an access list that does what? It's going to deny or block 10.1.1 from reaching these guys. Now, we know with the standard access list, I can only block based on the source, so I'm going to type in deny, hit the question mark, and it says, okay, well, do you want to match a specific address or a single host or any single host? Well, there's multiple ways I can do this. Let's do it the simple way right now. I'm going to do a single host. I think I said that backwards. It says any source host or a single host, right? So just host, and it says, okay, well, what address are you talking about? Well, 10.1.1.1. It works well in this case because notice scenario 2 says use a standard access list to block access to the subnet from the whole subnet. Then we wouldn't be using the host address. We'd be using a different way. So for now, I'm just going to say deny host 10.1.1.1. Enter, right? Now your job here is not done because you might remember from the previous nugget, what is at the bottom of every single access list? It is an implicit deny. So if I create an access list that just says deny 10.1.1.1, and then invisibly underneath it, it says deny anything else, right? And then I apply it to the interface, I might as well take that interface cable and unplug it, because I'm going to deny everything. I take down the whole interface. That's one of the reasons access lists are so dangerous, and you want to really be careful before you apply them to anything. So what am I going to do? I'm going to go in there and do a permit any at the bottom of that. Okay, let's bail out. Let's just do a show access list command on this router, and you can see right there. There it is. Access list block 10.1.1.1. Sequence 10, it squeezed that in there for us. Deny this guy. Sequence 20, permit everything else. Now, before you apply anything, can I share this with you? This is not part of the normal access list lecture, but now is as great a time as any. Reload in 5. You ever heard of that command? Reload in 5 says, I will reboot your router in 5 minutes unless you tell me not to. You're like, why would you do that? Because I'm telling you, it will save you so many times. I have been in so many situations where I'm working remotely from home or whatever the case is, managing a router in Mexico or some far away place, and I apply an access list, not thinking it all the way through or forgetting something or whatever to this interface, and all of a sudden my prompt never comes back. Ugh. It's usually 2 in the morning when that happens, and I have to call somebody, wake them up to drive down to the office and reboot that router. Tell them, oh, just unplug the cord and plug it back in to undo that command. Why? Because it's still in the running configuration, right? So I can bail out by rebooting and going back to the startup config. Now, iOS XR saves us with that because we can do kind of a conditional commit. We can commit it, but if it doesn't hear from us in so many seconds, it can uncommit and put back those changes without rebooting the whole device. But normal iOS can't do that. So this is the next best thing that we have is this reload in. So anyway, I'll just show that to you. I'm going to do a reload cancel because in all my talking, I'll probably forget about it. So now we want to apply it. Second most confusing things to access lists is how, where, what direction do you apply it? So in this case, we got to get our perspective. Let me just erase this out. We are sitting at 10.1.1.1, that's this guy, saying I want to block him from reaching 10.1.1.6, this guy and this guy. So we are sitting on this router. I'm going to apply it to this interface, and it's going to ask us what direction, inbound or outbound. The best thing that you could do when you're thinking about this is to literally be the router. I mean, stand up. Come on, right now. I'm talking literally. Stand up out of your chair. Come on. No one's watching you. Just stand. Well, if they are, you can tell them you're learning Cisco, right? Put your hands in the air like this. Smile, smile really big. Put your hands in the air like this, really far out. Here's your fingers. Wiggle them around. Wiggle, wiggle, wiggle. So put them like this and say, I am a router. Come on, say it out loud with me. I am a router. Here is my processor. Here's my memory. My torso is the core. These arms that I'm hanging out right now, I've got my right arm, my pen is on my left, hanging out right now. These are my interfaces, right? On the left side is serial 2/0. Okay, you can put your arms down. Tired, right? Serial 2/0. On the right side is fast Ethernet 1/0, right? So when you're thinking about the direction, this can, by the way, it's the number one thing that can devastate you. In this case, I would want to apply it in as things come in this interface, right? If you're applying it out, then that means, we're looking for 10.1.1.1 to be somewhere over here, and it's kind of going out here and being denied. So in is what direction we're applying. The reason it can be so devastating if you apply it the wrong direction is because you might end up blocking things that don't belong blocked because you put the router's perspective the wrong way. It's like, well, wait a sec. Private address shouldn't be coming from there or what, anyway. Very, very, very key piece to do. So this is going to be, if you lose access to your router, this is going to be where it is, right? So that's why we do that reload in command. So I'm going to come here. First off, you know what? It's no fun to prove that this thing is blocking without proving that it's working to begin with. So let's just do some pings to make sure that we are working. XR1 Cisco. So I'm sitting on router 3, who is the ambassador of 10.1.1ness. Right, so he has that interface. Let's just do a show IP interface. That's him, right? 10.1.1.1. So I'm going to do a ping to, let's do 10, squish it around, 10.1.1.6. 6. Ba-ching! We've got 5 ping successful. Let's go to the other side of the router. Ping 192.168.1.1, right? Going behind that router. How about 1.50? No. PC1 is down. Did I not configure that? Hang on. PC1 is really a router. Oh. PC1 doesn't exist. Hang on. Okay, well, let's make PC1 a reality real quick. How did I forget? I wouldn't have forgotten. Hang on. I created some copy and paste configuration right here. You want to see how I make a PC? Like that. I turn off routing on router 1, and I've said it just has default gateway. So this thing is no better than a computer. That's why I can say this router is a PC. So default gateway is there. Okay, now it's alive. We got some cable connector problem obviously going on there. But let's just do a ping 192.168.1.1. Okay, good. So it's up. Let's head back over. Let's just see if there we go. Okay, so good, right? We've got PC1. It's alive. Now let's come over to router 1. I'm going to go into interface serial 2/0, and I'm going to do the command to apply IP access group, and we will do what do we call it? Block. IPI block. There we go. 10.1.1.1, and then it's going to ask us, well, what direction? Inbound, right? Inbound. Good. Now I'm going to do a show access list because I want to show you something. Show access list. You can see right there, block 10.1.1. Look at this. It's already, the cool thing about this command is it shows you how many matches. It's already got a match on something. Something was permitted. What was it? Probably OSPF, right? Because I got OSPF running between these guys. So now let's come over here to router 3. Let's do the same thing. Hit the up arrow and bam, denied. Notice we're also getting U's back. What are those? ICMP unreachable. By default, when you apply an access list, it actually says, not only am I dropping these packets, but I'm going to send an ICMP unreachable message back saying you can't get here. Stop trying, instead of the request timed out. By the way, that might be something you want to turn off because that lets an intruder know there's something there, right? They would expect that if something wasn't there, you'd get this, request timeout. So sometimes stopping these ICMP unreachable messages is a good plan because it truly makes it hidden when something is out there. Okay, let's try ping 10.1.1.6, right? Same command as before. Bam, unreachable. Let's hop over to router 1 because we can hit the up arrow. And look at that. Yeah. We've got 10, deny, 10.1.1.1, 16 matches. So I'll hit the up arrow because it's probably... Oh, it went through already? Hit the up arrow again. There we go. So it's incrementing, continuing to increment as those are coming through. That's one of the fun things. By the way, access lists can even be a type of packet sniffer. I've used them so often for this. Like if I'm wondering who is coming in to this device, I can actually do an access list of all permit statements and find out, which ones are being matched, which devices are being accessed. If you turn on logging, which I haven't shown you. Oh, look at that. You can go into... access standard block. One of the commands you can do when you put these permit and deny statements is a little log. And then you can see if you type that in, it'll actually report to a syslog server right on the console output. Every single time an access list statement is matched, it'll put what source, what destination, all that kind of stuff. So it's kind of like a little poor man's Wireshark, if you will, that sniffs those out. Cool. So we are successful, right? We've got a standard access list that does that. Now, I'm sure some of you are like, really? Is each one of these going to take this long? No. That was like a full description of the syntax, full description of applying. The rest of these will be much faster. Let's look at number 2. Use a standard ACL to block access to the 192.168.10 subnet. Hang on, let me just clear all this off. That's these guys again. From 192.168.2.128/25. So that's these guys. Okay, so we've got to make sure that this subnet is protected from this subnet over here. Where are we again? Okay, well, looking at the mindset as close to the destination as possible, we're going to be, again, on router 1 because we want these guys to be able to cross all of these different networks and get to router 1 and be denied here as they leave this interface, right? So we're already clued into the direction outbound in this direction on router 1. Okay, so then let's put the syntax together. How do we do it? Well, we're going to go on router 1. Let's bring that back up into the picture. And let's come up with a less cryptic name for the access list. I'm going to do IP access list standard, and we'll just call it kill. All right, we're going to block them. So I'm going to say deny. Okay, this is where it gets a little fun. Deny, we're going to say what address to match. Is it any source or is it a single host? Well, now it's not either one of these. We don't want to block everything with this any. It's not a single host because we said block that whole subnet. So what do? We type in the subnet address. So 192.168.2.128 followed by the wildcard mask. Now, I know many of you probably have heard of the wildcard mask, know how it works, but I want to speak to those who don't. The wildcard mask is just that. It's wild because it's backwards from what it normally is. What is this subnet mask in decimal? 255.255.255.128 is the decimal form of that. The wildcard mask is always exactly backwards. So instead of 255, you see 0. Instead of 255, you see 0. Instead of 255, you see 0. Instead of 128, you see 127. Now, what did he say? How did he do that? One of the easiest way to figure it out is by taking the decimal subnet mask and subtracting it from all 255s. If you do this little mini math problem right there, that is actually the wildcard mask that identifies or is used to block the certain things. I mean, technically, what is the wildcard mask? It is an inverse of the binary. So when you have that binary subnet mask like I was showing you before, and this is not accurate because I'm squished in there, right? So 1, 0, 0, 0, all that kind of thing. Essentially, the wildcard mask flips all these to zeros, right? And then wherever you see the 0, so it would be .0, 1, 1, 1, 1. Those flip over to 1, right? And that's how we end up with these funky-looking wildcard masks that we have. So usually, rather than spelling it all out in binary, I just do something simple like this. Or after you do it for a while, you'll be quick to remember which values they are. Nonetheless, these are now, the reason they call them wild is because they are match bits. You line them up, right now we've got the syntax, where are we at, right there. We got the syntax saying 192.168.2.128, and we're lining that up with a wildcard mask of 0.0.0.127. What does that mean? Well, wherever I see a 0 right here, essentially that means look at this. Whoa, we're going to the wrong place. Over here. Look at this, right? 0. So look at 192. Look at 168. Look at 2. Oh, right there. And then 127 is that custom one that just says look at essentially 128 through 255. Identify those as valid addresses, and it just gets into the binary of how that works behind the scenes. Like if I were to identify a specific host, this is why I debated on that scenario 1. I could have said deny 10.1.1.1 0.0.0.0. That would have done exactly the same thing as that host keyword that I was using before, right? That's just a shortcut for really doing something like this. Matter of fact, if I would have typed this in and done a show run, you would see it actually squeeze host back in the front of it instead of this. It actually does that for you because it recognizes it. If I wanted to do this any keyword, right, with a address and mask, I could have done the address of 0000 and a mask of 255, 255, 255, 255, right? Essentially, that means instead of look at this like the zeros do down here, this says I don't care, I don't care, I'm matching anything. And if you were to type that in, if I were to come back here, let me grab this, I'll hit the enter key on that. If I were to type in permit, because I have to have a permit statement, permit instead of putting any, I could put 0 to 0 to 0 to 0 with a wildcard mask of 255, 255, 255, 255, enter. Now watch this. I'm going to do a show access list. And look at what it did. My access list kill is now sitting there saying deny this with this wildcard mask. And then it took my little wildcard combo right here and it said, oh, you really mean any. It translated that for me just by putting that in there. So that's how the wildcard mask works. And if you need more on that, there is a bajillion resources on the internet. Just type in understanding Cisco wildcard mask. Or, matter of fact, if you head over to the ICND 1 series, in that series, I take a lot of time to unpack the wildcard mask and go all through that. But for SPNGN 2, that's what we'll get. So let's test it. Let's just go quick and dirty, right? Router 3, iOS XR. Let's go in here, Cisco, and I'm going to ping with the source of this interface. And you know what? I just thought of something. Let's just let me do a show IP interface brief. show run interface 02/0. I think we still have, yeah. I'm going to yank that one off. I don't want scenario 1, and it won't, but just because. I don't want scenario 1 to interfere with scenario 2 in any way, so I'm going to remove that. Let's do a show run, take a look at that. Okay, good, good. So I just don't want that access list in the way. Did I apply this? I didn't apply this. Good grief. So show run interface fast Ethernet 1/0. Yeah, duplex half. Anyway, let's do IP access group kill. That's the access which we're applying. Outbound. So as it's trying to go out this interface at 192.168.1. Hang on. I never proved that this works before. Let's take that. Okay, now let's head over to router 3. Let's do a ping. Let's just do ping 10.1.1.6, right? Make sure we're getting there. Boom, success. So that validates that we are indeed traveling all the way from here down to here. Now let me do this. I'm going to do a ping 192.168.1.1. Success. Okay, so we were traveling from here down to here. Now I know you're like, well, wait a second. Should that? No, remember I didn't apply it yet. I haven't applied the kill access. I removed it, I should say. Let's just again make sure that I can ping all the way because I want to show you something. Ping 192.168.1.50, right? That's PC1. Good, success. Okay, good. We're getting there all the way from router 3. Now let's go into router 1, hit the up arrow, and say I want to apply kill outbound. Now let's go back over to router 3. I'm going to hit the up arrow and ping 192.168.1.50. Wait a sec. Why can it do it? Well, remember, when router 3 pings, it's going to come from a source of whatever interface is, essentially the closest interface to go there. So it's coming from a source of 10.1.1.1. So when it comes into the access list kill over here and says, let's just do a show access list kill. All right. When it comes in, it's saying, okay, are you 192.168.2.128. anything with that wildcard mask? And this guy's like, nope, I'm 10.1.1.1. And he goes, oh, okay, well, great, then you're permitted. So, well, how do we get to ping from this side of it? Well, you could go to that PC or on router 3. Oh, no, I don't. I want to do a ping to 192.168.1.50 from a source of 192.168.2.129. That's the gig 1/0/ or is it right? You see it right there, right? Enter there. Bam! Denied. Trying to think of something interesting to say. WWF SmackDown, something good. Good. And now we can verify that is actually happening there on the screen. So watch this. Watch me pull a rabbit out of my hat. So I'm going to go into IP access list. Kill, wait, hang on, standard, kill, and we'll do new show run, include access list, right? Just so I have it, let's do not include, but section access list. There we go, get all the commands. So I'm going to do a no 10, right? So what I've done is just yanked this command out of there, and I'm going to do 10, and then just kind of squeeze this one right back in. But I'm going to do a log on the end of it. There, because I mentioned this before, I just want to show it to you. Like I said, pulling my rabbits out of my hat. Okay, let's hit the up arrow, bing, and let's just see what's going on. Oh, hang on. Oh, there we go. It was there. I just missed it. Access list kill denied 192.168.2.129. Now, they actually have a built-in throttle on this thing. Even though it denied all of the packets coming through, it actually throttles it down because somebody could do a denial of service attack on your router if you had access list logging, because it's like, I'm logging all this stuff, and so it kind of groups all of these things into one. But nonetheless, it says right there, that's how I said it can be kind of like a Wireshark. You're like, oh, that's the guy who's trying to hack me, right? So good. Scenario number 2, check. Now, scenario number 3. Use a standard access list to block 192.168.2.50, that's this guy, from reaching the 10.1.1 address, that's this guy. I know you're like, okay, I got it. I think I'm good. So, as a matter of fact, if you want, go ahead and write it out on paper and say, what are the commands that I would do to do this? But I have a very specific reason in doing this last ACL statement right here, and that is because it allows us to create an ACL on iOS XR. So our goal is to take this PC number 2 right here and say that guy is blocked from reaching this WAN address, right? So that tells us we are going to be on router 3 applying the access list inbound right here. Now that will have the effect of preventing this host from reaching this entire subnet back here as well, but that's just the, we'll call it limitations of using a standard access list. So I'm going to come up here on router 3, which is our iOS XR router. Same kind of syntax. I'm going to go into global config mode, but instead of doing IP access list, we're going to do IPv4 access list because iOS XR is very IPv6 friendly. We can then just type in the name. Let's just call it block. All right. So IPv4 access list block, we will say that this is, and a little different. You can either go hit the enter key and go into the named access list configuration mode like we saw on the iOS in those first two, or the iOS XR allows you to type it all in one line. I can just say, well, I want to deny the host. You can see, again, a lot of the syntax combined to where you can say protocol. Essentially, think of it this way. iOS XR doesn't distinguish between standard and extended access lists based on typing in the name or the number that designate a standard or extended access list. Essentially, as you start doing this configuration, like for instance, if you type in an address, it goes, oh, okay, you're doing a source IP address, then you must be doing a standard access list. And I'll limit you to just allowing or denying based on that source. But if you type in one of these other ones, which we're going to talk about in the next nugget, these are protocols like TCP, UDP, that kind of thing. Then it goes, oh, you're doing an extended access list, and it'll open up all the options to do an extended access list. So iOS XR really is friendly if you think about it, in that it's like whatever direction you want to go, I will accommodate you. So I guess there really is no concept of standard and extended. It's just like what options do you want. So I'm going to say deny the host. Who are we denying? It was 192.168.2.50. And then right there it says, okay, well, you obviously went with the source address, so I'm not going to give you any other option other than logging because I can tell you're going the standard route. So we will define that. IPv4 access list block permit any, because we've got to permit something. And then we'll go underneath the interface. Let's see, what is this? G0/1/0/0. So interface G0/1/0/0. And again, instead of IP access group, we'll do IPv4 or 53,000 years from now. Access group block, and then same kind of thing. Ingress. So ingress or egress instead of in and out. So a little more clarity on that there. And now we should be good. So let's do a little test, shall we? I'm going to hop over to PC2. Do a show IP interface brief, making sure this guy truly is the right one. 2.1. Okay, good. We're there. So let's now ping 10.1.1.1, right? That's where we're going. Oh! It's like, well, that was anticlimactic, wasn't it? Sometimes I get so used to iOS. Look at that. We forgot to commit it. iOS XR, all these commands are taken, but we haven't committed as of yet. That was kind of funny. All right, let's go back to PC2, hit the up arrow, and good. We're being denied. And by default, iOS XR is blocking those ICMP unreachable messages because it's a little more secure. That's just Cisco's default with it. So now we have accomplished this. We also should not be able to ping 192.168.2.129. Let's hop on back over here and do a show IPv4 access. Actually, show access. There we go. Show access list IPv4. Flipping the syntax around always throws me off. There we go. So we've got our access list block, which allows us to see the access list commands that we put in there, the sequence numbers, that they're taking effect. We are good to go. So in this nugget, we have seen the access list concepts applied and put into action with the syntax on 3 different scenarios in front of us, both on iOS XR and iOS. Just like a video game, picking up the rocket launcher, the best way to learn how to use it, pull the trigger. So we've seen that in action. Now, next nugget, we're going to do the same thing, but this time spin it in the direction of extended access lists, which in my opinion are a lot more fun. I hope this has been informative for you, and I'd like to thank you for viewing.